Saxon, Algebra 1, Lesson 20. In this lesson, we study volume.
A cube is a three-dimensional box that has the same length, width, and height. A cubic centimeter is a cube that measures 1 centimeter on each side. Likewise, a cubic inch is a cube that measures 1 inch on each side. A cubic foot is a cube that measures 1 foot on each side, and so on. Cubic units, cubic centimeters, cubic inches, and so forth, also refer to volume and need not be in the shapes of perfect cubes. For example, a bucket would have a volume of 1 cubic foot if the amount of water it can hold is the same as the amount of water an open cubical container that is 1 foot on each side can hold. Suppose we have a rectangle that measures 2 centimeters by 3 centimeters. Its area is 6 square centimeters, and therefore we can cover the checkerboard with 6 cubes that are 1 centimeter on a side. The volume of this layer is 6 cubic centimeters, since it consists of 6 cubes, where each cube is a cubic centimeter. Now let's place more cubic centimeters on top of this layer until we have a solid that is 4 layers tall. The volume of this solid is the number of cubic centimeters it is made of. Since we have 4 layers, and each layer consists of 6 cubic centimeters, the volume is 4 times 6 cubic centimeters, which is 24 cubic centimeters. This shows that the volume of a box can be found by multiplying the area of its base by its height. The base is 2 centimeters by 3 centimeters, so its area is 6 square centimeters. And the height of this object is 4 centimeters, so the volume is 24 cubic centimeters. Here is a right prism. It is 6 centimeters tall, and each base is an isosceles triangle as shown. The area of the base is 4 centimeters times 8 centimeters divided by 2, which is 16 square centimeters. Since the area of a base is 16 square centimeters, we can construct a layer on it with a height 1 centimeter and volume 16 cubic centimeters. Because the prism is 6 centimeters tall, it can be made from 6 of these 1 centimeter tall layers. So the volume of this prism is 6 times 16 cubic centimeters, or 96 cubic centimeters. Again, we multiply the area of a base by the height of the solid. From these two examples, we observe the following. The area of the base of a right solid can be interpreted as the volume of a layer that is 1 unit high. The height of a right solid can be interpreted as the number of unit-high layers it is made of. And so the volume of a right solid is equal to the volume of a layer times the number of layers. Therefore, the volume of a right solid is equal to the area of a base times the height of the solid. Now let us apply this to some problems. Problem 1. A right cylinder, a right circular cylinder, has a radius of 6 inches and a height of 11 inches as shown. Find the volume of this right cylinder. Dimensions of the picture are inches. The volume of any right solid is given by the formula volume equals area of base times height. The bases are circles of radius 6 inches, so the area of a base is pi times r squared, which is pi times 6 inches squared, or 36 pi square inches. And therefore the volume is 36 pi square inches times 11 inches, or 396 pi cubic inches, which if you use a calculator multiplies to 1,243.44 cubic inches. Problem 2. A base of a right solid 10 kilometers high is shown. Find the volume of the right solid. To find the area of the base, we add the areas of its rectangle and semicircle. The rectangle is 5 kilometers by 6 kilometers, and the semicircle, we use the formula pi r squared and divide by 2 because it's half of a circle. And so if we use a calculator, we have 30 square kilometers plus 14.13 square kilometers, which is 44.13 square kilometers for the area of the base. The volume, therefore, is the area of the base times the height, and if we multiply those two together, we get 441.3 cubic kilometers for the volume of this particular object. Problem 3. A base of the right prism 8 meters high is shown. Find the volume of the right prism. The dimensions are in meters. Well, we have to find the area of the base, and then we can multiply that by the height, 8. To find the area of the base, we split it into a rectangle and a triangle. We find those areas. The rectangle is 6 by 4, so it's 24 square meters. And the triangle is 6 by 6, so it's half of 6 times 6, which is 18 square meters. We add those and we get 42 square meters for the area of the base. We then multiply that area of the base by the height, 8 meters, and we get 336 cubic meters for the volume of the solid. Problem 4. A base of the right solid shown has an area of 52 square feet. The height of this solid is 15 feet. Find the volume of the solid. We already know the area of a base, so we need only multiply this by the height in order to find the volume. So the volume is 52 square feet times the height 15 feet, which gives 780 cubic feet. This is the end of Lesson 20. Your assignment, problem set 20 on pages 90 and 91 of your book.